The world often feels vast and unchanging, but there are places where the consequences of climate change are unfolding faster than many people realize. One of those places is Antarctica, at the very edge of the planet. Scientists from Britain and South Korea are working together there on a mission that could reshape how we understand the future of our world. Their goal is to study one of the largest and fastest changing glaciers on Earth and to uncover what is happening deep beneath its frozen surface. This glacier sits in West Antarctica, a region that plays a critical role in global sea levels. It is enormous, roughly the size of a large country, and it behaves like a keystone within a much larger system of ice. The glacier holds back a network of other glaciers that slowly flow toward the ocean. If it were to collapse or melt significantly, it would no longer restrain that ice. The result would be a massive release of frozen water into the sea. On its own, this single glacier contains enough ice above sea level to raise global sea levels by several centimeters. While that number may sound small, the amount of water required to raise sea levels even 1 centimeter across the entire planet is immense. If the surrounding glaciers were also released, the total rise could reach several meters. That level of change would be devastating for coastal cities and low-lying regions across the world. Places like New York, Mumbai, London, and countless island nations would face frequent and severe flooding, especially during storms and high tides. What makes this glacier especially concerning is its position. Much of it rests on bedrock that lies below sea level. Warm ocean water is able to reach underneath the ice, melting it from the bottom. As the ice thins, it becomes more unstable and begins to move faster toward the ocean. Satellite observations show that this process is already accelerating, raising urgent questions about how quickly the glacier may change and what that means for humanity. To answer those questions, scientists are undertaking an extraordinary research effort. They are drilling deep through the ice, sometimes more than a kilometer down, to reach the point where the glacier lifts off the seabed and begins to float. This area, known as the grounding line, is where warm seawater interacts directly with the ice. Understanding the temperature, currents, and conditions at this boundary is essential for predicting future melting. The work is taking place in one of the most remote environments on Earth. West Antarctica is isolated even by Antarctic standards. Reaching the glacier requires long flights over endless fields of ice, followed by helicopter journeys across fractured and crevassed terrain. Only a small number of people have ever visited this specific location. Those who have described it as otherworldly, a vast frozen landscape that feels completely alien. Surviving and working in these conditions requires specialized equipment and careful planning. Scientists wear multiple layers of high-performance cold-weather clothing designed to protect them from temperatures well below freezing. Despite the extreme cold, the constant daylight of the Antarctic summer means the sun shines around the clock. When the sun reflects off the ice, it can feel surprisingly warm, even as the air temperature remains dangerously low. The drilling process itself is a remarkable feat of engineering. Teams heat water and use it to melt a narrow shaft through the ice, progressing meter by meter. This allows instruments to be lowered into the depths to measure temperature, pressure, and movement. In some cases, scientists also drill into the sediment beneath the ice, extracting cores that reveal layers built up over hundreds or even thousands of years. These layers provide clues about how the glacier behaved in the past and whether it has ever melted or retreated before. The ultimate aim of this research is not just to observe change, but to understand it well enough to plan for the future. Climate change is often compared to slowly turning up the thermostat in a house. Even a small increase in temperature can have long-lasting effects. Once the planet warms, the consequences continue for centuries. Ice sheets respond slowly, but when they do change, the impact is enormous and irreversible on human timescales. Some scientists believe that the glacier will eventually melt significantly, regardless of what actions are taken now, because the climate has already warmed. The key uncertainty is how long the process will take. If it unfolds over several centuries, humanity may have time to adapt by building defenses, redesigning cities, and relocating vulnerable communities. Accurate predictions allow governments and societies to prepare rather than react in crisis. Hearing this can be unsettling. A timeline of hundreds of years can make the problem feel distant, yet in the context of human history, it is not very long at all. There is a responsibility to future generations to leave behind a world that is safer and more stable than the one inherited. Decisions made today will shape coastlines, ecosystems, and human settlements far into the future. Early findings from this research suggest that warm ocean water is indeed reaching the base of the glacier and accelerating melting. The outlook is concerning, though scientists caution that much more data is needed. The scale of the effort involved highlights how important this knowledge is. Dozens of flights, months of preparation, and international cooperation are all required to gather information from a place that once seemed untouched and unchanging. For those who have visited the glacier, the experience can be deeply emotional. Standing in a landscape so vast and seemingly eternal, it is striking to realize that human activity has influenced even this remote corner of the Earth. Glaciers that once moved imperceptibly are now changing in measurable and rapid ways. What was once expected to be a slow and stable field of study has become dynamic and urgent. Despite the gravity of the situation, there is reason for hope. The same global cooperation that enables this research also demonstrates humanity's capacity to respond. Scientists, engineers, pilots, and support teams from different countries are working together toward a shared goal of understanding the planet and protecting its future. That collective effort shows that while the challenges are immense, so too is the potential for solutions. Understanding the Earth is the first step toward preserving it. The work being done deep beneath the Antarctic ice may help guide the choices that determine the fate of coastlines, communities, and generations yet to come.